Welcome back, everyone. Today we are going to learn about evaluation metrics and rank systems. We have four metrics that we are going to compare with: hit rate, MRR, faithfulness, and correctness. So, hit rate is whether the right chunk was retrieved at all or not. This is going to check how many chunks that we retrieved that were right by total number of chunks. MRR is mean reciprocal rate, that is the average of the reciprocal of the ranks. Say your relevant chunk is supposed to be ranked 1, but what if it is ranked 5? So we are passing 4 unrelevant chunks that are in top 4 ranks, and then the most relevant chunk is ranked 5. So that is not what we want, right? So lower the values, better. So that's why we are going to take reciprocal of that. In the later slides, we are going to analyze what is faithfulness and correctness. They're self-explanatory. This is just what their meanings are. So, hit rate is the binary measure that the system retrieves the current chunk within the top k results. So, this would be the base thing. If hit rate is very low, that means whatever your metric is high or not, it doesn't matter. It never had the right information. So, that is not a good response. Mean reciprocal rank, if that is, this is supposed to tell you the average of the ranking, so we always want a good number, we don't want a wrong number. Say, since we are taking reciprocal, we don't have to always look for the lower values here. Then the previous two measures were evaluated during the retrieval stage. Next, we will understand during the generation stage what would happen with faithfulness and correctness. Faithfulness is total number of claims that are made, that is in favor of the context, by total number of claims completely done all over. And correctness would be judge score by max score. Faithfulness is how right your, or how much is it faithful to your actual information, and correctness is whether the generated answer is right or not. So strong retrieval does not guarantee the right answer. It always depends on how well the context is understood by the model. That's what we're aiming for. To improve our rack system, we will have certain strategies that can make it better depending on how what is the level of your evaluation scores. We can always look at better chunking strategies. We can make use of semantic chunking. We can make use of more intelligent ways of chunking that are going to perform way better than just fixed size chunking. To understand the structure, say you have headers, so it would chunk based on a certain section of a document rather than a certain paragraph. Then we have hybrid retrieval that would combine BM25 and vector search to capture both lexical and semantic matches. That means you're going to consider the structuring of the document as well as the meaning of what is written inside them. We'll learn more on this in the future videos. Next is having better re-ranking strategies. We can apply a cross-encoder re-ranker, or we can explore multiple ways where we can see the ranking is done much better, so that we don't have most relevant chunk as rank 5. We always want it to be rank 1. Another way we can fix the faithfulness and correctness aspect is to improve the prompt strictness. Like when you give in the system prompt, you infer to only use the context, don't go out of the context, use the only relevant chunks. You can improve, you can reduce the temperature, and that's how we can make better choices and make LLM make better choices while giving certain answer. Key takeaways: RAG is retrieval plus LLM. We have to evaluate both of them. Either one which is not working well will not yield a better answer, hence, it would be a problem for the users. We wouldn't want that always, and especially in production systems where it's very critical for us to always give the user the right information, as well as reducing our cost and problems and trade-offs. Retrieval quality is critical, very important. If we don't have the right information, then we definitely cannot give the right information to the users. It might just come out of inherent information from the model, but it may break any day. So that's not what we want. We are always evaluating at each stage, even with the retrieval and generation. That's how we get a better model. For optimization, we can look into chunking, hybrid retrieval, rig ranking, and prompt design, each of which we'll learn in the future videos. So that's it, how we can make RAG in a production scale and evaluate it much better. I hope you liked the video. Thank you very much. Please subscribe.